Now we have to take the next point, magnetic lines of for a circular loop. Here in a previous topic we discussed the magnitude of this magnetic field if I is the current flowing through them and R is the radius of this circular loop. Then the magnetic field of induction Bz along this central axis, z axis, is mu 0 I r square 2 into z square plus r square raised to 3 by 2. This we discussed in a previous topic. If this z is equal to 0, if this z is equal to 0 in this equation, then the corresponding this equation becomes Bz is equal to mu 0 I r square upon 2 into this z square is becomes 0 plus r square raised to 3 by 2. If this is 0, then this total answer will be r square. Then this r square and this square root will get cancelled. Therefore, this equation becomes mu 0 I r square divided by 2 into r cube. This r square and here it remains only 1. Therefore, magnetic field of induction along this will be equal to mu 0 I upon z into r, 2 into r. Call this equation number 5. Call this equation number 5. This is the magnetic field of induction. If there is only one term, then this equation becomes mu 0 I upon 2I. If there are n number of such terms are present, then this equation becomes Bz is equal to mu 0 upon Ni upon 2R. Call this equation number 6. If there are n number of terms are there, then this equation becomes Bz is equal to mu 0 Ni upon 2R. Here this magnetic lines of force along this part, suppose this one is a circular loop. If I amount of current is flowing through this loop, there are these circular loops are as like this. Here this one is in clockwise direction, here it is in anti-clockwise direction. These loops are present, these are the magnetic lines of force are present due to this circular loop. Now we have to discuss the circular loop. If this circular loop, this current in this magnetic dipole is present. At this time, if we say that this Z is very far away from this point, that means we say that this Z is too much greater than this R. Then there is this corresponding equation will changes as like follows. At this time, we say that this into this equation, we say this Z is very greater than R. Then we neglect this R. This corresponding equation becomes Bz is equal to mu 0 I r square upon 2 into Z cube. This becomes 0 and this square and square root get cancelled. It becomes Z cube. Call this equation number 6. Now from this equation, this is the magnetic field of induction at this point. Here we know that this area of this is a circular loop. Area of a circle is pi r square. Area of a circle is pi r square. Then this equation changes as like this. Bz is equal to mu 0. Here this is I. Instead of r, we write here a. And here for this pi is not present, we write here pi is divided by 2 into z cube. Now the magnetic moment of this magnet is m is equal to I into a. Instead of this Ia, we substitute here small m. the corresponding equation it changes as Bz is equal to mu 0 into n upon 2 pi into z cube. This is the equation for this magnetic field of induction. Now, if we multiply this equation by 2 and divide by 2, this 2 2's are becomes 4. Then this magnetic field of induction Bz is equal to mu 0 upon 4 pi into 2m upon z cube. This is the equation for the magnetic field of induction. Magnetic field of induction due to the dipole. At this time, here note that this equation is similar to the electric field. E is equal to 2p upon 4 pi epsilon naught r square. Here, which is the electric field at the axial point due to the electric dipole, and this is the magnetic field due to the magnetic dipole. Okay, thank you.